Welcome back, everybody. Mr. Rashid here. And what we're going to do today is look at section 1.7c, which is graphing and writing piecewise word problems. And the specific learning objective here for today is I can write piecewise functions and create graphs from situations. And situations is another word we can use for word problems. So some of you may have seen or remember this from one of the earlier videos where I had 4 of these up there. So equations, graphs, situations, tables, different kinds of representations of the same thing. Now, in this video then, we are looking at piecewise functions, and we are taking situations and then turning those situations into a piecewise function with all the equations in there, or we're taking that situation and we're turning that into a graph. So those are the 2 things we're going to look at. Now, we'll do some review examples for piecewise functions first, and then at the end we'll have a problem that looks at a situation and then turns it into an equation and a graph. And for some of you may be good at that point, and you can go on and work on the homework. Others may need to see more examples, and then I've got 2 separate videos with 2 additional examples if you want to check those out too. Okay, so let's take a look. So these are the review problems, reviewing how we can evaluate piecewise functions. So we've got this big thing here with the curly brace, and in this particular piecewise function we have 3 different parts to it, and each of those parts is defined in its own line, and we have the function part of it here, and then this part, the second part here, tells us when does that particular part of the function apply. And so let's look at this here, f of 1. So what that says is I'm going to input 1 into this function. And when I input 1, I've got to decide now with this piecewise function, well, which one of those actually apply to what I'm dealing with here. So 1, that's going to fall between 0 and 3. So what I'm going to do next is write, so I've got the negative x plus 1, that's what I'm going to use, negative, then parentheses plus 1, and whatever's in my parentheses here, I'm going to plug that in there. So this is 1. So I've got negative 1 plus 1, and that is just 0. And we're done there. Okay, so let's do the same thing with a couple more of these to get the idea. So we have 8 here. So I decide, where does that 8 actually fall into? Which one of these sections of this piecewise function? And the 8 goes between the 3 and the 9. So that's the thing that will apply. And here, this just says 2. Now remember, f of x is another name for, we could also put y there. So what this is saying is y equals 2 for all of the parts where it's between 3 and 9. And then also remember, if it's equal to 3, then it also works for y equals 2. So f of 8 then is just, the output of this is just 2. Okay, so we've got 2 more. So f of negative 2, where does that go? So we've got to decide, in looking at this here, which part of this piecewise function applies. So on a number line then, we would see that the negative 2 would fall between negative 3 and 0, so that's where we are. And we can use this x plus 1 part of it. So what I do, once again, when I'm applying or evaluating functions, is I write, wherever I see an x, I write parentheses down, then plus 1. Very, very simple functions we're dealing with here. So then the negative 2 goes wherever I put those parentheses before, so negative 2 plus 1, and this is negative 1. Okay, so then we're done with that. Then the last one is the 3. Now, this is a very uh, the only one in all of the cases that we looked at where it's actually on the boundary. So I see a 3. Let's erase this. So I see a 3 over here, and I see a 3 over here. So which one actually applies? It's the only one with an equals sign that I'm going to use. So that is the very last part of this piecewise function. That's where x actually equals 3. So in that case, we have, once again, y equals 2 or f of x equals 2. So very simply, then, this is 2 also. Okay, so that's just a quick review of how to evaluate piecewise functions. Now, this is also review, and we are looking at how to graph piecewise functions. And going back to the video, you remember that Ms. Jensen talked about drawing different kinds of different zones. And those zones, you can put lines on those boundary values to define those zones. And the first interesting boundary value here for this problem is where x is equal to 0. So this function below x equals 0, there's nothing there. And that's very common in real life situations where negative values won't mean much. So that's a good example of that. Then the other boundary value is x equals 3. That's where things change for this situation that's associated with this piecewise function. There's something happening there at 3 that makes things change. So the 3 is the boundary value, and I've got that actually in blue. That's my next boundary value there. The one in black here was this x equals 0. And then the last one where things are changing up is where x equals 6. So that's the interesting boundary value where things start to happen and the function goes in a different direction. Okay, so for the first part of it, so everything between 0 and 3 and also including the 0, we have a very simple case. We saw this on the last slide. We have y equals 9 or f of x equals 9. And so we've just got a steady horizontal line going through y equals 9. So on this graph here, we let's use the black part of it to represent that. So this is just 9 there. Then the next part of the graph is a negative 3x plus 18. And let me look at this here. So exactly at 3, I don't know if this function is going to jump or not yet. So I'm going to put an open circle on that because it's at x equals 3. I'm not sure what this function is going to evaluate to with that negative 3x plus 18 yet. But I do know for sure that at x equals 0, the y equals 9 or f of x equals 9 applies. So I'm going to put a solid circle there to represent that. Now, let's evaluate. So negative 3x plus 18. Now, the 3 definitely is included in this, let's call it the blue section here of our piecewise function. And so what happens if I plug 3 in to that? So I've got negative 3x plus 18, and I want to evaluate this at 3 to find out what's going on. So I'm going to put in a 3 for my parentheses here. Negative 3 times 3 is negative 9 plus 18, which gives me 9. So what's happening now is that it's still equal to 9. It's a type of function that doesn't jump or do anything strange. It actually just stays at that 9 and it's going to start at that 9. So now what I can do is for the blue part, I can actually fill in that open circle. So this second part of the piecewise function now filled in that circle for me. And now I can use this is linear. So at your boundary value, you can simply use your slope, which is -3 is my slope here for this. So my rise over run I can write as -3 over 1. So I'm falling down 3 and running over 1. You always run to the right, from left to right. And if it's negative, you're falling. If it's positive, you're rising. So I'm falling 3, running over 1, falling 3, running over 1, and there you go. And notice now at x equals 6, I can't use this blue part of the function, so I'm going to put an open circle there. And then the rest of it is my line. Okay, then now from 6 to 10, we've got our function in red here. So let me erase some of this. So we've got our function in red, and that is saying half x minus 3. So let me erase some of this here. Now, let's look at the boundary condition. So the boundary is at 6. That's where things are changing. So which part of this piecewise function applies for the 6? The third part of the piecewise function where we have half x minus 3. So let's write here, we want to evaluate what happens at 6. So I put in half x, or let's use my my rule here, or trick. So I'm going to put that wherever it's got x, I'm going to put the parentheses, and then half, this is going to be 6. I can put that in there. And so, well, no need to rewrite all this. This is just 3 minus 3, which is 0. So once again, it's not jumping or doing anything strange. This red part of the piecewise function, I'm going to fill in that empty circle there, because now this red part defined says, hey, we are at 0 for this part of the function. Now, once again, with linear, what you can do is look at just the slope here. So here we have rise over run equals 1 over 2. So we're rising 1, we're moving over 2. So let's rise 1, move over 2, rise 1, and move over 2. Remember, we're starting at this 0, y equals 0 value. So this then is my line. And then at 10, remember 10 is not included, right? It's not equal to 10 for this piecewise function. So then I've got my open circle there. Okay, so that is, if you're just working in pencil, you wouldn't have all this in different colors. You would just mark the different spots where you would have an open circle or a closed circle. So that is it. That's how we would do that particular piecewise function. This is a continuous piecewise function. If you had your pencil on one side of the paper to the other, you would not be removing. You would not take your pencil off the paper to actually go and trace a line over this graph. Okay, now this video is getting a little bit longer than I thought, so I'll break here, and then I'll have 3 separate examples, 3 videos for the separate examples for how to take situations and write graphs from them or write piecewise functions. Okay, thank you, and I'll see you again in the next video. Bye.